This is lesson 44, VHDL example 26. And in this example, we'll design a 8 to 3 priority encoder. Now, you remember that a priority encoder, you can have more than one input 1. That is, all these lower don't cares could be 1s, and the highest priority is the one that gets the output. So for example, x3, you remember, you get a 3 here even though some of these could be 1s. x7 is the highest priority. If x7 is 1, you'll get a 1 no matter what's here. So the question is, how can we do this? Well, we designed logic equations, and those were sort of complicated. But let's see if we can use a for loop here like we did with the regular encoder in the last lesson. And so let's take a look. Here's a priority encoder. X is the 8 input, 7 down to 0. We'll still have our valid output. And Y will be the output 2 down to 0. Now, I claim that this architecture will be a priority encoder. So take a look at it and see if you can see any difference between this and the one we had for the encoder in the previous example. Well, if you look closely, you'll see that it's actually identical. It's the very same program. So how can this be a priority encoder? Well, let's look. We say for j in 0 to 7 loop, if xj equals 0, then y gets j, converting the standard logic vector like we did before. But this is a signal assignment. Remember how signals work. When does y get updated? Not till the end of the process. So we go through this for loop. Suppose that suppose j is 0. Suppose x0 is 1. Well, then y will be 0. Suppose x1 is 1. Y will be 1. Well, it's the last one which gets assigned, which actually gets assigned at the end of the process. Therefore, it becomes a priority encoder. If x7 is 1, it'll be the last one through the loop because we're going 0 to 7. So you must go in this order, 0 to 7, for this to work. Then y will get 1, 1, 1. That is, convert standard logic vector of 7. Even though some of the early ones can be 1. Anytime through the loop, of course, valid would get set to 1. So this same architecture, in fact, designs a priority encoder. We can test it with this simulation. Here we'll use a binary counter to get a bunch of different 1s in here. So if they're all zeros, valid is 0 and the output's 0. Here x1 is the highest priority even though x0 and x1 are both 1, but the output y is 1. Here the output's 2 because x2 is the highest priority even though x1 is also 1. Here x3 is the highest priority for all of these 3 cases even though you've got other 1s down here. Here x4 is the highest priority, the output's 4. Here x5 is the highest priority, you get x5. So in fact, this is a priority encoder. You can design a top-level design and play with it on your board. Make the switches 7 down to 0. We'll connect those to those will be the inputs. The outputs will go to the LEDs, the rightmost 3, and the decimal point will be the valid signal. So we'll set the decimal point to not valid. Here's the component for our 8 to 3 priority encoder. And we'll just port map it. X goes to the switches, Y to the LEDs, and valid to valid. So you can download this program to your FPGA board, and when you turn the switches, now you can have more than one switch on, but the rightmost LEDs should give you the highest priority switch that you have set.